lines, and now we're starting with vector planes. So first we'll have to understand the vector equation of the plane and the Cartesian equation of the plane, and then we'll start off with the cases. So let's say we have a plane here, and so generally we denote a plane with a capital pi, just like you have a small case a and a capital A, uppercase letters, small lowercase letters. Same way, even the Greeks had lowercase letters and uppercase letters. So this is a small pi and this is like the big pi. Like you have a small sigma and you have a capital sigma. So generally, capital uppercase pi is used for planes. So I'm just using that. So A is a known fixed point on the plane. As you can see, the vector A is a position vector for the point A. P is any point on the plane. R is the position vector for the point P. And N is a vector which we call the normal vector because it runs perpendicular to the plane. So if you remember for direction vectors, we took a vector that ran parallel to the line, and we called it the direction vector. For planes, we take a vector that runs perpendicular to the line, and we call it the normal vector. Okay, so if I were to make a vector between A and B like this, let's say this is vector A and B, then by simple addition of vectors, can I say that A plus AP equals R? Can I say that? By simple addition of vectors, A plus AP is equal to R. So then does this imply that vector AP is R minus A? Can I write like this? Okay. Now we just agreed on a few things. Then A is a point on the plane. We already know the coordinates of A. P is any other point on the plane. And AP is a vector which is connecting A and P. Now if A and P both are on the plane, do you agree that the vector AP is also on the plane? Do we agree on that? Alright. There is a vector that is running perpendicular to the plane which we call the normal vector. If your vector AP is on the plane, then do you agree on this that the vector AP is perpendicular to N?
Yes.
Do we agree on this? If N normal vector is perpendicular to the plane, then the normal vector has to be perpendicular to AP as well. So if we agree on that, then as AP is perpendicular to the vector N, can we say that AP dot N equals 0? Can we say that? AP dot N equals 0. So does this imply that R minus A dot N equals 0? Can I replace the AP by R minus A? This is your vector equation of the plane. This is your vector equation of the plane. And there are two forms. I call this form 1. There is another form of the vector equation as well, but from this point on we can form the other one as well. But this is your vector equation of the plane.
So A is the fixed point.
A is a known fixed point, just like you had A as a known fixed point on the line. A is a known fixed point, whose coordinates you know.
Then what is R in this case?
R is the position vector of any point P on the plane, any random point.
The vector is R dot N equals to
I'm coming down. Are we good till here? Any questions? So this is your vector equation of the plane, and I call this form 1 because there's another form. The other form comes from the fact that you open up the bracket. If you open up the bracket, then this should become R dot N minus A dot N equals 0. Now if I take A dot N on the other side, this implies that R dot N equals A dot N. Now A is the position vector of the known fixed point. That we know the position vector A. N is also a vector that we know. We already know the vector, the normal vector which runs perpendicular to your plane. Which means that if you know both these vectors, then A dot n is a value that you can calculate. The dot product gives you one single value, a scalar value. So that means A dot n can be calculated easily. So we can say that as A dot n is equal to some scalar d, let d is any value. D is not the direction vector, d is just a value like A, B, C, D is a value. Then can we say that R dot n equals d? This is your vector equation in the second form. So this is also the vector equation of the plane. Vector equation of y, but I call this form 2. So if you are asked to make the vector equation of the plane, you can make it in any one of the forms. And if the question is giving you the vector equation of plane, the vector equation of plane, they can give you in any one of these forms. So you will instantly, when you look at it, you will instantly recognize it. If it's given with equal to some scalar value on the right side and r dot n, or they could give it this way, where you can easily identify that this would be the fixed point on the plane. Any questions? Are we good? At the back? Alright. Now, once you have this form, the second form of the vector equation of the plane, you can easily get to the Cartesian equation. So, we know that R is any point on the plane, right? Which is x, y, z. So, can I write x, y, z dot, okay, let's say R is any point of the plane x, y, z, and let's say let the normal vector be a, b, c. Because we already know the normal vector, let's say the normal vector is some 2, 3, 4 or whatever it is, a, b, c. So then this form becomes x, y, z dot a, b, c equals d. This implies once you take the dot product, x times a, y times b, z times c, you will get this. Ax plus by plus cz equals d. This is called the Cartesian equation of the plane.
So parametric नहीं
Parametric नहीं. That's not in the course. You do have a parametric equation for the plane, but you don't need it. Are we good till here? Any questions? Let's take some values and let's make an equation for the plane, then you'll understand better. Are you done copying?
Sir, please के lecture में
You copy them. I haven't done. You guys need to copy all this because this is not in the lecture book. So you have to copy all this notes.
कितने केसेस
ऊपर जाते
10 साठ आप 10 ज़्यादा नहीं
बस सिर्फ
ज़्यादा नहीं
थोड़ा सा
सर लाइन इसके भी 8 और 16 केसेस टोटल
If we had done the vectors before that, let's start this. Just need 1 week. One or maximum 1.5. About zero. Take 1.5.
Total
Are we good? Should we move on? Alright. Case 1. Guys, copy this down. Vector and Cartesian equation of a plane part with known fixed point and normal vector. I repeat, vector and Cartesian equation of a plane part with known fixed point and normal vector. So this is the easiest case we're starting with. You already know the fixed point, you already know the normal vector, you just have to form the vector and the Cartesian equations. So let's take a scenario. Let's say there is this plane and the plane passes through a fixed point A with coordinates, let's say 2, 1, 3, and there is a vector that runs perpendicular to the plane, and let's say that vector is -1, 1, 2. So, what is the vector equation of this plane? Let's first make the first form, then we'll make the second form, and then we'll make the Cartesian equation. So the first form is r minus a dot n equals 0. This is your first form. So you know even lines r just remains as r in the equation. So r is just r minus a, we already know 2, 1, 3. And just put a box bracket, dot. Normal vector we know -1, 2, -1, 1, 2 equals, this is your vector equation of the plane. One of the forms. Look for form 1.
So don't you expand it?
Form 2 maybe. So you're done with your vector equation here, till here. Now if you want it to be in the other form, if you want it in form 2, then you open up the bracket.
Sir, R is the position vector.
R is the position vector of any point on the line. So if you open up the bracket, you know this would become R dot -1, 1, 2 minus 2, 1, 3 dot -1, 1, 2 equals 0, which, or you can just do it directly if you remember R dot n is equal to A dot n. That will give you the second form, you can do it directly, but because we have this, so I'm just opening it up. So this is R dot -1, 1, 2 equals, now this goes on the other end, and after the dot product you should get a constant value on the right side, which I am calling as D generally. Is it 5? r dot minus 1 minus 2 equals minus 2 plus 1 plus 6 plus 7 plus 5. So this is the other form of the vector equation of the plane. So when you're asked for the vector equation of the plane in the question, you can give it in any one of these forms. Are we good? Any questions? Alright, now from this point on, the Cartesian equation is very easy. All you need to do is just have an x, y, z here, and you know, by the way, if you notice, in the Cartesian equation, your a, b and c, the coefficients of x, y and z, those are the components of the normal vector. So if you know the normal vector, you know the right side already, you can directly make the Cartesian equation. So if I were to make the Cartesian equation from this point on, I would say this is minus x plus y plus 2z equals 5. This would be the Cartesian equation of the plane. So the components of the normal vector become the coefficients of x, y and z respectively. And on the right side, you've already calculated that through a dot n. Vector equation of the Cartesian equation. Are we good? Any questions? Okay, let's move on to case 2. Is anyone still copying? So we're moving on to case 2. Case 2 is determine and confirm points on a plane. How do you find out more points on the plane, and how do you confirm whether the point lies in the plane or not? Let's take a scenario. Let's say the equation of the plane is let's take the same equation, this one, minus 1, 1, 2 equals 5. Let's take this. Now, can you find out at least let's say this is the plane. Part A of my question is, does 1, 1, 1 lie in the plane? So the best way is that you convert this to the Cartesian form. That's the best way. So your Cartesian form for this, by the way, is coming out to be minus x plus y plus 2z equals 5. Any point that lies in the plane or a point lies on the line has to satisfy the equation of that line or plane. Which means that this point 1, 1, 1 has to satisfy the plane equation. So how do you decide on that? You will plug this point here in place of x, y and z and see if it also gives you 5 on the left hand. If it balances the equation, it lies in the plane. If it doesn't satisfy the equation, it doesn't lie in the plane. So let's plug in 1, 1, 1 here. not equal to 5, so 1 comma 1 comma 1 does not lie in the plane. It's not in the plane. Does -2 1 comma 1 lie in the plane? That's my question.
Yes.
So we'll plug -2 1 1 in the equation in the Cartesian, see if it satisfies the equation or not. -2 comma 1 comma 1 lies in the plane. It satisfies the equation. Everyone's okay with this? Any questions? So, what's the catch here? What's the procedure? If you were to write a bullet point for this, so we say, yeah, convert the equation in the Cartesian form and plug the coordinates of the point into the equation, into the Cartesian equation. Convert the equation in the Cartesian form and plug the coordinates of the point into the Cartesian equation. And then obviously, if it satisfies the equation, it lies in the plane. If it doesn't satisfy the equation, it doesn't lie in the plane. Simple. Are we all okay to hear?
Plug the coordinates of the point into the
Plug the coordinates of the point into the Cartesian equation. Now my part C to this is find 2 points. Find 2 points in the plane. Yeah, find 2 points in the plane. So what you need to do is, again we make use of the Cartesian form. So the Cartesian equation is -x plus y plus 2z equals 5, right? Now get me 2 points that lie in the plane. Now for this the procedure is very simple. What you do is, you take any 2 variables, either xy or yz or xz, any 2 variables, and you give them random values, any value that is convenient to you to use. Give them those values and find the value for the third variable, and you get your point. What I'm trying to say is this. Let's say let x equals 1 and y equals 0. Then what point are you getting? So I'm randomly putting x as 1 and y as 0. So x is 1, y is 0. So my z value that comes out is 3. Therefore, one point which is surely on the plane is 1, 0, 3. This point is definitely on the plane. Same way you can randomly put any value, maybe a value y and z, and find x.
So but in this equation, because it's like very simple, so we can just put all three, like -2 to 1.
All three, that means you already know the point.
नहीं दो are used.
वो कह रहा है तीनों डाल दो.
Like, is that the question says the multiple points. So, if I just like make an equation by myself, then what next? If I just put my
No, my intention over here is to find points on the plane. I'm not confirming a point, I'm trying to find points on the plane. If the equation doesn't give me the points, I have to find them from the equation. So for that, I'll have to give two random values to two variables and find the third one. So you can get millions of points on the plane by keeping the various different values.
This is like a oversimplified equation, right? So it's like a more complicated equation, more complicated function than how you find.
How complicated will this equation be?
It's like numbers simplified together, like you have to have different forms.
आप दो variables को zero कर दो, तीसरा निकालो. That's the simplest you can. That's why I'm saying any convenient values.
Yeah.
See, what I'm going to do now is, let's take your case over here, and let's say, let y equals 0, and let z also equal to 0. Let's find x. That's the easiest way over here. So minus x plus 0 equals 5. So x is minus 5. Therefore, another point on the plane is minus 5, 0, 0.
और बाकी दोनों 0, 0 में दो या 2 points.
You can put any value. Are we good? Any questions? Any questions till here?
No, sir.
Okay, let's move on. Case 3. Case 3 is angle between planes. How to find angle between planes? So, okay, can we just write a description procedure for this one before we move on to case 3? Sorry. What would be the procedure?
Assign random values to any vector variables.
Assign convenient values. Any random.
I don't put random.
Assign random values
To any two variables and find it.
to any two variables
And find it random.
and find the value for the third one. For the third one. That's the procedure. Assign random values to any two variables and find the value for the third one. Using the Cartesian form. Are we good? Using the Cartesian form. Okay, I'm moving on to case 3. Case 3 is angle between planes, and it's a very simple case. All you need to do is use the dot product on the normal vectors of the two planes. So all you need to do is apply dot product on the two normal vectors. So basically what you're doing is this: n1 dot n2 equals n1 mod n2 mod cos of theta. So use the dot product on the two normal vectors and find the angle between the two normal vectors. The angle between the normal vectors is also the angle between the two planes. Explanation is very simple. Let's say this is okay, I'm representing the plane with a line just for convenience over here. This is, let's say this is one plane. This is one plane. and let's say there's another one here. So this is my second plane. If I intend to find the angle between the planes, all I need to do is I'm going to find the angle between the two normal vectors. So let's say this is the normal vector for the first plane. This is the normal vector for the second plane. If I'm using dot product between normal vector 2 and normal vector 1, I will end up getting this angle right here. And this angle, by the way, is equal to this one right here. By simple geometry, you can figure out that this angle is the same as this one. See, these two angles are 90 because they're normal vectors. This one is 180 minus this, and this one is 180 minus this one, so these two tend to become the same. So all you need to do is find the normal vector, the angle between the normal vectors, and you'll get your angle between the two planes. And you know if your angle comes out to be obtuse, because most of the time your question will ask you for the acute angle. If it comes out obtuse, what do you need to do? Subtract it from 180 and you get your answer. Are we good? Let's take a case. Let's say one plane equation is minus x plus y plus z equals 10. And the other plane equation is 2x plus 3y plus 5z equals, let's say, 6. So what's the angle between the two planes? So we use the dot product between the two normal vectors. So this is root 3 and this one is 25 and 9. 24, 34 and 4. Root 38?
Yeah.
38. So 55 point. So that's the angle between the two planes, 55.8 degrees. You know, if it came out obvious, you would subtract from 180 and get the required answer. Is everyone okay with this?
Yes.
Yeah.